Hi guys, for today's lesson we're going to be dealing with differentiating the exponential function. So first up, just some words to remember within this topic. First up is the constant e. What do I mean by this constant e? Well, e stands for Euler's number. It's a letter which represents the value 2.71828, and those decimal places do go on forever. It's very similar to like pi, but pi is like 3.14159, etc., whereas e is this value here. The exponential function is an exponential function with e as the base. So we pretty much got y equals a base of e, this constant e, Euler's number, to the power of x. So if you remember that typical exponential functions usually is something like y equals 2 to the power of x, but the exponential function is when our base is this Euler's number here, e. When I graph the exponential function, it looks like a typical exponential function. It has a y-intercept of 1, and when x is 1, the y value is this value of e, because like e to the power of 1 is just going to be that value of e. Now note that the gradient at the y-intercept is 1. It's a 45-degree angle when it hits there. So you can kind of see that if I draw a tangent at that point, it makes like a 45-degree angle with the x-axis. So some rules to remember. The exponential function is particularly important in calculus because its derivative is the same function as itself. So this is the basic rule. This is why this sort of function, the exponential function, is very useful, because it has this unique property. So if our function is y equals ex, the exponential function, its derivative is exactly the same thing. The derivative is the same function, i.e., if they're both equal to e to the power of x, that suggests that y is the same as dy dx. Y is equal to dy dx. Now y, when we look at this sort of graph, y is represented by this line here. It's pretty much representing the height of our function. So for example, at this point here, our y value is e, which is the height from the origin. So it's like this length from the middle up to there. So it's like a height from the x-axis. That's going to be equal to dy dx, which is representing the gradient. So pretty much like the height is going to be equal to the gradient of this purple line. So like for example here, at this point right here, the height is e. The gradient at this point would also be e. Here the gradient is 1 because the height is 1. So like up here, 1, 2, 3, 4, 5. If we go to the line there, the gradient at this point would be 5 because that's what the y value is there. Okay, so we can use this property to differentiate functions that involve exponential functions. So say if we want to differentiate this is a little bit different of an exponential function. It's got the base e, but it has a bit of a unique power, 3x plus 4. So the strategy is, when we're differentiating this sort of thing, is that we want to use the chain rule, letting u equal the power function. So the idea is we can, instead of having this strange looking power, we can change that to a u. We can let u equal 3x plus 4. So let u equal 3x plus 4. We can find du dx, which is going to be equal to 3, the derivative of this function. So if we're differentiating u in terms of these x's. And also, if we change this to a u, we've got y equals e to the power of u. If we differentiate this, we get dy du equals exactly the same thing, because e to the power of u is differentiated, does not change. That's like similar to e to the power of x. That's the only function that won't change when you differentiate it. And if we remember that our chain rule is this formula right here, we have to multiply our du dx by our dy du, and we get this, which is going to be e to the power of u times 3, which is 3e to the power of u. And eventually we have to change our u back to what it's equal. U is got to change back to 3x plus 4, and we get this as our derivative. So the alternate strategy to get this a lot quicker is to pretty much take your function, and we want to multiply this thing by the derivative of this power. So the derivative of this power is 3. We can literally just multiply this function by that 3, and we get this same answer. So our answer is 3 times e to the power of 3x plus 4. So it's pretty much just a nice quick strategy. It's pretty much doing the chain rule nice and quickly. Okay, let's try another one. Differentiate this function right here. First up, I want you to realize that this 4 down the bottom is just like multiplying by a quarter. Multiplying by a quarter is the same as dividing by 4. And that will not affect our derivative. So we can pretty much ignore that and just differentiate this part with our x's. Okay, so we're going to take the derivative of our power. The derivative of this is going to be 2x plus 3, all in brackets. That comes to the front of our function, and the quarter is just going to stay out the front, not affecting anything. And this is going to simplify to this. I pretty much put my quarter back down the bottom as a division of 4. Lastly, a bit of a harder one, y equals the square root of e to the power of x. So firstly, when we're differentiating, we don't want to have to deal with these square root signs. So change it to a power of 1/2. You'll notice that when we do that, we see a power of a power. They're going to multiply. So x multiplied by 1/2 is going to give x over 2, or x divided by 2. And when we differentiate this sort of thing, we can take the derivative of that power and bring it to the front. The derivative of x over 2 is just 1/2, and our e to the power of x on 2 just comes down. So that is our derivative. We want to simplify it a little bit. Our multiplying by 1/2 is the same as just dividing by 2. And let's get rid of our fractional power here in our derivative. So the way that we do that, we need to split up our x over 2. And see how this was originally something that looks like this. We can go back to that. So our x over 2 is the same as x to the power. The power of x to the power of 1/2. And then finally our power of 1/2 can change back to our square root symbol. And we get this as our final answer. Tick. Hope this helps with the questions. Good luck.